Hi, so in this video, we are going to look at the actual code for our basic 2-input AND gate. So both the design and its test bench will be done in this video. I am going to explain every single line of the code, okay? So before starting the explanation about the code, I shall suggest you to go through the whole explanation of this EDA Playground website first. I have uploaded the two links of those videos in the description. Go and check it. As those basics will be not explained in this video, the main focus will be in the code. Okay, so let's dive in. So before starting, I want to share another thing that this video as well as the future video which I shall upload, like how to do the basic OR gate, NAND gate, NOR gate, half adder, different combinational circuits or sequential circuits, all those code will be written in the VHDL format. Okay, so we have to do the setup according to the VHDL only. Okay, so all the code will be given in the VHDL format, and we shall also set up our machine as the VHDL format only. So before starting, we have to do the setup. So at first we have to go towards the left panel where all different type of things are written, like languages and libraries, tools and simulators, examples, etc. Okay. After that, we have to click in the languages and libraries. After clicking this, we can see different type of parts are present, that like test bench plus design, libraries, top entity, etc. So at first we have to click the test bench plus design part. So click on that arrow button. After that, you can see huge number of coding languages are there, like Python only, C++, Python plus SV, different type of. Okay, but we will do our code in the VHDL. That's why we shall click in the VHDL part. Leave the libraries. We do not have to click anything on the libraries part. Right now, we don't have to fill up this top entity. Later, during the execution or during the running the program, I shall show you what is the purpose of the top entity. Okay, so leave the enable V unit also. Now next move towards the tools and simulators part. See, after clicking, a select box is present. So click on the select box. You can find a huge number of simulators, synthesizers. Okay, there are like commercial simulators, commercial synthesizers, free simulators, etc. So for this we need commercial simulators, and that is Aldec Riviera Pro 2023.04. Okay, so click on that. After clicking that, you can see that different type of option get increases, like compile options, run options. These are new thing. So leave the compile options. Don't change it. Whatever value is present in your computer, keep it that. Okay, don't change it. So leave this run options also. Runtime, leave this runtime also. Okay. So after running our program, what we need to check that our program is giving the output correctly or not. For that we need the diagram, no, the wave diagram, where AND gate, OR gate, or different type of gate will show their wave. Like after giving the input as 0 0, what is the output is coming. After giving the input 0 1, what output is coming. So we need to know this. So for that we need the wave diagram. For this we have to click the checkbox open EP wave after run. Okay, this is one of the most important checkbox you have to click, so that you can get the EP wave diagram after run. So click on the checkbox. After clicking this, the whole part which need to be done during the code, means the left side part, is complete. Now we have to do our code in the design.vhd and testbench.vhd. Okay, I think you have seen a change in the code, means in the design part also, the test bench also. And what is that change? We, after clicking on the languages and libraries after the test bench plus design, when you click on the VHDL, this two line which is present in the design and test bench, that is library IEEE, then use IEEE.std logic 1164.all, these two line automatically add in this two part, that is both in design as well as in the test bench. I think you have noticed this change after clicking on the VHDL. Before it was different, but after clicking the VHDL, the two line of this code has changed. A comment also added in the portion, that is code your design here and code your test bench here in the test bench part. Okay, so before start our coding, we have to understand that why this part is written, that library IEEE, then use IEEE. Why we need it? At first we have to know what are they. Okay, this is us telling the compiler to load the standard rule book for digital design. Okay, and why do we write it? We write it because you know that VHDL is it is a huge language. So by default, it doesn't actually know what a digital signal is. It is one of the important thing. Okay, so that's why the IEEE library contains the package of std logic 1164, which defines the system of 0, 1 or any alphabet like X and Z that we use for wheres. Okay, and the main thing is why, means what happens if I don't write it, or if we don't write it. If we delete these lines, the compiler will crash immediately, because it will look at the code, see std logic and say that error. Why error? Because the compiler will tell that I don't know what type this is, because we didn't use the library of IEEE, and we also didn't use the std logic package also. How could a compiler know that what is that code or from which package it has been taken, because it is not defined if you delete it. So that's why we have to write this two line of code. This will automatically generate after clicking on the VHDL only, but we have to keep it. If we delete these two lines, then error will be shown in your computer after running the code. Okay, so you simply cannot write standard VHDL without this. So this is the important part. Okay, so we have understand that what is this two lines are telling us, or why do we need this. Okay, so let me break down deeply so that you can understand the value of this both line. Okay, so I have told you a word, that is the compiler. Now what is the compiler? Compiler is the builder. Okay, think of the compiler as a construction worker who is ready to build your chip. Okay, and they are smart, but they don't know everything by heart. This is the main thing. Okay, they just know the basic grammar of the language. Okay, so this is the compiler. Now the standard rule book, I think you remember that I have told you one word, that is the standard rule book. That is to load the standard rule book for digital design. Remember that? That standard design or standard rule book is the library IEEE. By default, VHDL is a very general language. It does not, or it doesn't actually know what a wire is or what voltage is. It just knows abstract math. And the problem is, if you just type, means you have taken a signal, suppose like signal X, and you have given a signal S std logic, then colon, semicolon, signal X semicolon std logic colon. Then the compiler looks at you and say, I don't know what std logic is. Is that a number, a word, a fruit, a animal, or what, man? I don't know. So for that, the solution is we have to write the library IEEE, then semicolon. This line, which we are handing the compiler a specific dictionary or rule book written by the IEEE, the official engineering organization. Okay. Now I have also said a word, that is digital design. The digital design part is the use IEEE.stdlogic1164.all. This specific chapter of the rulebook defines the language of digital electronics. And what is the specific chapter? That is the package 1164. Okay. It tells the compiler, hey, in this design, we are going to use things called 0, 1, X and Z. Means X, what is defined as the X is basically defined as unknown, and here if we write as Z, it defined as disconnected. Okay, remember this represent electricity on the wire. Okay, so this is the explanation of those two lines of the code. I am writing the code, check it, learn it, and also write the same code in your computer also to get the output. Okay, you have seen the code. What I have written, I have written as entity and get is. Now let's expand this. What is that? What exactly is a entity? The entity means the word, the entity is basically the black box. Think of an entity as a physical casing of a microchip. If you were holding a real AND gate chip in your hand, you would see a small piece of plastic with metal legs sticking out. Yes, this is the physical AND gate, okay? You can't see the millions of transistors inside, but you can see the legs. I think you know, if you have done the offline version of this digital electronics, like using the AND gate chip or gate chip, you have seen that the IC which are present, those are covered with a black coating with 12 numbers or 14 numbers of legs type of thing, which you have to connect those things in the box where you also put the wire and get the output. No, but what is present inside that black coating, you never saw that, and that is the millions of transistor. Okay, so in VHDL, the entity is the interface. It defines the face of your component to the outside world. It tells other components that here is my name and here is how you plug into me. Okay, so this AND gate means entity AND gate is basically telling or basically showing the outer, means outer part, means think like that. This entity AND gate means the black coating is present and different pins are getting out. Okay, so think like that. This is the interface, but inside that, if you don't cut it or if you don't break it, you cannot see those million transistor is present inside the black coating. If you break that thing or if you cut that thing, then only you can get to see the millions of transistor inside the physical AND gate. But if you don't break it, you cannot see. You can only see the outer coating and those legs are present. Okay, so that is defining as the entity AND gate. Okay, after this I have written a word, port. Now before explaining this port, I want to tell you that you have seen in my code that I have giving some space, then I am writing port. After that I shall also write something like A, B, Y, in, out. Okay, I shall write those things also. In that time also I shall give some space. Now this giving space is not a mandatory thing. Okay, as I am explaining to you, it will look beautiful as well as a well structured like a program which you done in your code like C or Java. The indentation, okay, this is for the beautiful indentation so that you can see the program line by line, that which line is present under which portion for better view I am doing this, or I am giving the tab space or normal space. Okay, so if you want you can give this in your code also, or if you don't want, no need to give, the program will run successfully. Okay, if your code is written correctly without any spelling mistake or any minor mistake. Okay, so see here I have written port. The port means, you know what is the port? Port means the pins which you saw in the physical AND gate. Some pins are out, means those legs are basically known as pins. So here we are defining those pins as port, and I have opened a first bracket, because inside the first bracket I shall write what are the pins I shall take in the AND gate. Means what are the, how many input I will shall take, how many output I want to get. This all thing will be determined in this port. Now see, after writing this port, I have written A colon in ST logic, then semicolon. You have to give the semicolon. Okay, semicolon is must. After that B colon in STD logic, semicolon. Then Y colon. After that out STD underscore logic, then bracket close semicolon. Okay, now this keyword port is like a signpost that says, attention, the following list is my physical connection points. Okay, inside this port list I have taken in, 2 in, that is A and B, and 1 out, that is Y. In means the in are the ears of the chip. They listen for signals from the outside. That means those A and B are the input, okay, of this AND gate. And out, this is the mouth of the chip. It speaks or sends signals to other parts of the system. Think like it is a output. Okay, without the port keyword, VHDL wouldn't know which names are internal variables and which names are physical wires you can actually touch. Okay, so this is one of the important thing. This port have to be given to specify your input, that how much or how many things you want to give inside the AND gate, and how many output you want. We are giving 2 input, 1 output, that means 2 input AND gate this is. Okay, after this we have to close this entity AND gate, means the AND gate is closed, means the structure has been created, black structure, then pins is also are present, that we need 2 input, so that's end, entity has been end. Okay, now you can check that we have written in std underscore logic, the part std underscore logic. What is that? Why we have to write this thing? In basic math you only have true and false. You heard the term boolean, right, which only give the output as true or false. So in the basic math you also know that we have true and false. But in real hardware, electricity is messy, and this is one of the true thing. We use this std underscore logic because it is realistic. It doesn't just represent 0 and 1. It represents a real wire that could be 0 or 1, means low or high voltage, or Z, that means high impedance or disconnected, like a wire floating in the air. And in the same way it also can give the X, means the unknown or conflict, like 2 signals fighting over one wire. This output can be also get from this std logic. So using std underscore logic makes your code hardware aware. It ensures that the computer simulates real physics, not just abstract math. Okay, so we use this to ensure the computer that we are using or we are checking the real AND gate, not just in programming words. Okay, so that's why we need this std logic. Now another thing will be strike in your head, that what will happen if I don't write it, means the entity part. And you know what is that? It is the disaster scenario. So if you skip the entity, your VHDL code is essentially a ghost. You might have a architecture describing logic, but the logic has no home. The compiler will give you a syntax error because it has no idea where those signals like A, B, Y are coming from. They don't know So we have to give this entity. It will also can give the even worse situation, like if you forgot just one port, say you forgot the input B, you have created a broken component. When you try to use this AND gate in a larger project, you will find that you have no place to plug in the second wire. It's like buying a TV that has a power cord but no HDMI port. Okay, so you have a great device but no way to get information into it. Okay, so think like that. So this is one of the important part. You have to give this entity part, or you have to write this entity part in the design.vhd. Okay, now we move from the cell to the soul, the architecture part. This is one of the most important part. Okay, so I have written the code as architecture behavioral of AND gate is. Now what exactly is a architecture? Now think like that, if the entity is the plastic cell and the metal pins, okay, means I have told the physical chip or physical IC, no, that is the black code with 14 or 12 number of pins. So think like that, that if an entity is a plastic cell and the metal pins, the architecture is the internal wiring and the silicon logic, those millions of transistors present in the IC, no. So I'm telling that only the internal wiring and the silicon logic. It is the only place in your code where you describe how signals actually flow. In VHDL, we separate the what, means the entity part, from the how, the architecture part. This is a superpower because it means you could technically have three different versions of a brain, one fast, one small, one simple, that all fit into the same physical chip cell. Okay, so I think you have understand the architecture part, means where the means the behavior or what cell do that, means the black coating and with pins that IC, what cell that IC will do, that part or that internal structure is present inside this architecture. Okay, so after this we have written the word that is begin, means we are starting that begin. Okay, we will do this word, this work, sorry, so we will do this work. Let's begin like this. Okay, begin. Then we have written as y means the output. Y is the output. What output shall we get, means which output, from where the output will be get, from the Y pin. So y will be the output, and what the work or what the input A and B will do, they will do the AND, means A and B. See the arrow, left side arrow means left side, like less than then equals to, means we are telling that y equals to A and B, and here equals to is assigned like this, less than then equal to. This means left side, this A and B is entering, or this A and B result will be come out from the y pin or y wire. Okay, so like this, A and B. So after this, the part is the behavioral of AND gate and underscore gate. Now the VHDL is very organized. You have to give your architecture a name. So the name we have written, means the architecture name we have written as behavioral. Now you can use the, means if you think that no, I shall not use this behavioral word, I shall use AND, or I shall use something different like your name only, so you can use that. There is no mandatory that you have to write behavioral only. I have written here, you can also write different thing also. Okay, now after this you must to say, means the architecture, you must say that of AND gate. Why? Means Whose architecture is this? It is AND gate architecture, no? So you have to write the architecture behavioral. Whose architecture? Of AND gate architecture. Okay, like this. Think of this as binding the guts to the body. If you just wrote architecture behavioral, the computer would ask behavior of what? I have told in the previous only. Okay. So behavior of what? What man what? So by saying of AND gate, you are officially plugging this specific logic into the pins we defined earlier in the entity. Okay, so without this link, the inputs A and B would have no way to find the logic. Okay, now see the keyword as, or you can say, yes, we can say it as a keyword because you have to write this. What is that? That is begin. You have to write. Means you have write that architecture behavioral, whose behavior of AND gate. Now let's begin. Okay, let's begin. Let's begin. What shall the work will be done by this AND gate? Let's enter into the depth like this. Okay, so we have to write this begin. So now the after begin we have written as y equals to, means the symbol as less than equals to. You can say that also A and B. Now I shall tell you first to look at the symbol that is less than equal to. What is that? We are telling that this is a less than equal to. No, absolutely not. In standard programming language that you have done like C, C++ or Python, we use equals to now. What? A equals to 5. Means we're assigning the 5 into the A. A is storing what? 5. Or what the A is giving as the output? 5. Like this way, in the VHDL, this is a signal assignment operator. This y less than equals to means that y equals to A and B. Okay, so this is the VHDL signal assignment operator. Okay, think of it as an arrow. Okay, it means that take the electric result A and B and drive it onto the wire named y. Okay, in hardware this isn't just a one time calculation, it is a continuous connection. If A changes at any microsecond, the result is immediately pushed through that arrow to the output. Understand? And what the output will be given, or means what will be the output of the y, that is A and B, means 0 and 0. The result will be come out from the y pin, or you can say that y wire. Okay, 0 and 0, the result will be come from the y will decide that what will be the output. Okay, so after that we have to write the end architecture behavioral. In the same way we have written as end entity AND gate. In the same way you have to also end or close the architecture part. Now the main thing is what happens if we don't write it. It becomes the empty chip. Means if you leave the architecture part empty or forget the logic line, you have created a paperweight. Imagine what shall we imagine? What shall we take an example? Imagine that you are buying a calculator that has all the buttons, the ports. Okay, if we talk in the language of VHDL, then we can say that those are ports. Okay, all the buttons means the ports, and the screen, the output screen is present. But when you open it up, there are no wires inside connecting the buttons on the screen. You can press 2+2 all the day, but the screen will stay blank. In the inside, nothing is present. Means the entity is present, means the IC is present with the black code and pins, but inside that there are no transistor or nothing is present. Then how shall it will be work, or how shall it will give the output now? So in simulation your output y will show up as a red line, u or x. I have discussed in the previous only what is u or what is x. Okay, as because it is uninitialized, nothing is telling that where what voltage to have. It become a dead circuit. Okay, understand? So no architecture equals to no logic. This is one of the most important thing. So we have completed our discussion about the design part. So this is the part 1 video in which I have explained the whole code of the design.vhd part line by line and word by word. In the next video I shall explain the test bench part. Okay, so till then keep learning and bye bye.